Let us now look carefully to definitions of execution. What we can see is an observable behavior when processes do invocation and then they get responses. That observable behavior is that before we call trace, sometimes in the context of shared memory is called history, but it is a trace or history of observable sequence of events. So every trace then consists of a sequence of events of the following type. This is a read invocation, this is a read response, and this is a write invocation, certain value to write a certain value v, and this is the corresponding write response. So as you can see here, because processes are sequential, so whenever we have a response for any operation, we know to which corresponding register it was associated. Since each process executes one operation at a time, mapping responses to requests is well defined. So now let us look to some properties of shared memory traces. So a trace is, we call it well-formed, if the first event of each process is an invocation, and each process is sequential. Each process alternates between invocation and responses. We are going to assume that we have only well-formed traces. Now let us see some definition of specific traces. So some traces could be what we call sequential traces. So what is a sequential trace? A sequential trace is a trace where invocation of any operation is immediately followed by the corresponding response of that operations. And a response of some operation immediately follows the corresponding invocation. So this just tells us that the trace is sequential. We complete one operation at a time, and then the next operation starts and completes, the third operation starts and completes, and so on. So a sequential trace then, if we have this operation O1, O2, and O3, so it is like saying I first do an invocation of operation O1, whatever that operation is, followed by a response. I will call it one response of the set operation, response, followed then by the invocation of the second operation with its response, and then followed by the invocation of the third operation and the response. So these together, invocation and response, is one operation. This is O1, this is O2, and this is O3. And that is what we mean by a sequential trace. Now, a trace is legal, and that's a concept that we have to remember. We will use it later when we look to consistency condition on traces. This is really defined what are the allowable traces. A trace is legal if that trace is sequential. And now, if the trace is sequential, then all operations are ordered. Therefore, we can, at any operation, we can talk about what is the last previous operation. So a trace then is legal if it is sequential, and each read to some register X returns the last value written to that register. And because a trace is sequential, again, the last value written is well-defined concepts. So if the last value written to a register was 5, and then the following read has to return the value 5. Now let us look to other definitions. So in a trace T, we say that an operation is complete if both the invocation and the response of that operation occurs in that trace T. These are very intuitive definitions. A process starts an invocation, and if it gets a response, then the operation is complete. If a process just starts an invocation and never gets a response, then we call the operation is pending. This can happen in a distributed system. That's why we are defining this concept. We say that a trace is complete if every operation is complete. Otherwise, some operation did not complete, then it is partial trace. And here comes a very important concept. As we just alluded to, processes do invocation and responses. So some operations from different processes will overlap in time. But we would like also to talk about in real time which operations precede other operations. So an operation op1 precedes another operation op2 in a trace if the response of op1 in real time precedes the invocation of the other operation in that trace. Observe, a trace is just describing what happens in a system. It is a history of the sequence of events in real time. So if an operation's response happens before the invocation of another operation, we say that this operation precedes the other operation. So otherwise, the two operations are concurrent. So let us look now to execution at two processes. We have two processes, P1 and P2, and we have two registers, X and Y, and they have initial value 0. And this is a timeline that we describe it one line per process, but it really describes also traces where things happen. So P1 starts actually a write operation. So this is a write operation at P1, which would like to write the value 1 to register X. But how it does it? It does it by doing an invocation here, and the operation completes with a response here. But this is the write operation. Here is a read operation. This is a read operation at register Y, which return the value 1. And this is the invocation, and this is the response. At process P2, we have two corresponding operations. This is a write operation with the invocation response here. This would be write Y equal 1. And this is a read operation, which is reading X, and it gets the value 1 here. All right. So if we take all these events and we put them in one line, we get the trace that we are talking about, which is a sequence of invocation and responses. So that is a trace. Second, you can see from this that each process is sequential. It does a complete write before it starts a new operation, which is read. So why it is sequential? It has an alternating sequence of invocation and response starting from an invocation. And the same happens for process P2. So this execution is well formed. Each process starts with an invocation, and it alternates between invocation and responses. This trace, as you can see, is not sequential. Because certain operations overlap with each other. And you can see here that we have an invocation followed by a next invocation. So this is not sequential. Now, interestingly enough, now we have operations which are concurrent. So this write here is concurrent with this write here. Whereas this operation is definitely after this operation. Why is that? Because the response of the operation, this operation, is before the invocation of this operation. You can see it here, that the operation right one, which is actually this one, is definitely before the invocation of read x here. So now we also understand what does it mean for operations to overlap and one operation to precede another operation.